Today's video we're going to talk about congruent triangles, two triangles that are identical. We're going to talk about the congruency statements that we can make as a result of these triangles, and then we're going to talk about this concept of CP/CTC. And exactly, yes, what is that? We'll get to that in a little bit. But first and foremost, you want to make sure that you're ready and prepared to take some good quality notes. All right, let's get started. As we begin to embark on our congruency portion of this unit, we want to keep in mind that order matters, right? This is a big deal. The order in which we say things does matter. Now that we have that squared away, what are congruent triangles? They're triangles with the same shape and size. Same shape and size. Now, if we have the same shape and size, if we actually do have congruent triangles, that means that all their corresponding parts with respect to both angles and sides are congruent, right? Everybody's the same. So when we talk about congruency statements, first we're going to look at this picture right here. And what I see is I have triangle ABC over on the left side and triangle DEF on the right side. Now how do I start making sense of what's going on? First I look for similarities. So I see that angle A over here has a single arc and angle D has a single arc, making those two angles congruent, right? And I look at angle B here, and that has a double arc, and E has the double arc. So if you notice in your statement over to the right, it says triangle ABC is congruent to triangle DEF. Well, why? If order matters, why did we go in that order? Well, the triangle on the left, the first statement that we say, can say it in any order we want. So we said A, then B, then C in terms of vertices. So A is my single arced angle, and over here on D, I start with D, I have to stick with the same angle that corresponds to that, right? Corresponding parts. This idea of this angle corresponds to this angle. Then I moved on to the double-sided angle, or the double arced angle rather. And I notice that that's B and E respectively on each triangle. So if I go from A to B, then I have to go from D to E. The last letter standing here is C, and the last letter standing here is F. Now it should be good to note that over here on this first triangle, side AB, segment AB has a single mark. AB are the first two letters. Who's the first two letters over here? DE. I go over to DE on this triangle. That has a single tick mark too. So that is the correct side matched up. First two letters with first two letters in my statement, go with those sides. We'll continue on and we'll emphasize this concept of order matters more. Back to this CP/CTC. All that does is correspond to a set of words. It's an acronym. And that acronym stands for corresponding parts of congruent triangles are congruent, right? So corresponding parts. If you had two triangles side by side, this top left side corresponds to that top left side, if these are indeed congruent triangles. If that's the truth, then the top rights should also be congruent. And if that's the truth, the base of each of these triangles should be congruent as well. Then you move on into the angles. Well, then this angle should correspond to this angle, and this angle corresponds to this angle, and the third angles correspond to each other as well. Corresponding parts of congruent triangles are congruent themselves, meaning if the two big pictures are identical, then all of the little pieces in them are also identical as well. Okay. So now to use these congruent statements in action. Order up at the top here is really what's going to matter. Now who comes first in this statement on the left? J. Who comes first on the side on the right? Angle P. So angle J is going to be congruent to angle P simply because they're both first. Now who's in the second position? Angle K is going to be congruent to angle Q. And of course the last one on the left and the right is going to be angle L is congruent to angle R. Now what about the sides? The sides are going to roll very similarly in that we pay attention to our order. JK is the first two letters mentioned on the left side, and PQ are the first on the right. So segment JK is going to be congruent to segment PQ. Keeping on in that fashion, KL is going to be congruent to QR. So segment KL is congruent to segment QR. And then the first and last, segment JL, is going to be congruent to segment PR. Now if you look down at the bottom of the screen, what I have is two triangles drawn. And what we had up here is that J was the same as P, and K was the same as Q, and L was the same as R. Now I used a different amount of tick marks because I don't really know that those angles are all the way the same. I just know that J and P match up, K and Q match up, L and R match up. But I don't know that it's isosceles or equilateral. I just assume that they're all different angles. Now in the red, I see that JK is the same as PQ. So JK is the same as PQ, and KL is the same as QR, and the bases are the same. Now in the original statement, we started at J, made our way to K, and then down to L. And we followed the same with this triangle on the right. What they want me to do is to write another valid congruency statement. So essentially, take this statement up here and just change the order. So if I just said, instead of JKL, what if I said triangle KLJ? Well, then that would change things on the right. If I started with K on the left, I got to start with Q on the right. And if I went from K to L, I'm going to go from Q to R. And then after L, I go all the way back to the front to J, so I must go all the way back to P. So that's one of three valid congruency statements I could write. Okay, let's move on. Now that you have one version, I'd like for you to complete number 2, press pause, and then come back to me. Now we're ready to take this to another level. So we have this congruency statement up here. This is going to be key. I know that angle K matches up with angle A, so I'm just going to put a little arc here and a little arc there. And I know that P matches up with Y, so I'm going to put 2 marks here and 2 arcs there. And then M matches up with C, so I'm going to put 3 here and 3 here. Now I'm going to change the color for the side lengths. And I know that KP is the first 2 letters, so KP matches up with AY. PM matches up with YC. So YC and PM. And then the third sides also match up. So now, that's a nice visual representation of what's going on. But if I just hold on to the fact that, again, order matters, right? It's an important concept that order matters. I'm just going to use the order, the order of my statement up here is really what's going to help me answer all of these questions. So, for instance, A starts with KM. K goes to M. Well, then that's A to C. I just pay attention to the order and make sure I put the same notation. Segment KM is the same as segment AC. They're congruent. Onward to B. C to Y. CY is right here, so MP is the order of my next answer. Segment MP is congruent to segment CY. How about PK? PK goes from P to K, so that's going to go from Y to A. Moving right along, angle Y is congruent to angle P. Angle K is congruent to angle A. And angle ACY, getting just a little trickier, keep in mind the middle letter is the vertex. So if C is the vertex, then M is going to be my vertex over here. So if I start with ACY, that's A to C to Y, that's going to be K to M to P. So angle KMP. The triangle statements are no different on the end here. For G, I just have to pay attention to the order. So follow along on MPK. I go from M to P to K, then I'm going to go from C to Y to A. Triangle CYA. On this last one, YAC, YA to C is going to be PK to M. Triangle PKM. That's it. It's just about following order and being diligent about paying attention. Now that we have all of this congruency practice, we're really ready to start answering some real questions. So in the statement up here, angle S is the same as angle B. So whatever it says on S, I can put for angle B. So that's going to be 67 degrees. And now I have two of the three angles of a triangle. So if I add 67 and 82, I get 149. And when I subtract 149 from 180, I get 31. So 31 is going to be this angle right here. But angle N is the same as angle W. So this is 82 degrees. And if it's 82, 67, 31 on the other triangle, then these guys are the same too. And again, angle T is the same as angle F according to my congruency statement. So because the statement says that those two triangles are congruent, then again, by CP/CTC, congruent parts of congruent triangles are congruent themselves. I piece together all three angles. Now I think I can come over here and answer all of the questions that they asked me. Note, fill out the picture first, right? Fill out the picture first. It will make your life so much easier. So as we move through D, E, and F, D asks for the measure of angle W. Angle W is 82 degrees. And I didn't really need to do any math. I just needed the congruency statement for that one. Angle B is 67 degrees. Again, no math necessary to answer that one. And then using the triangle sum theorem, that all three angles add up to be 180, I was able to get an angle F is 31 degrees. Now let's move back for the sides for parts A, B, and C. For side BN, BN's right here, and I look, that's B to N, so that's going to be the same as S to W. I look over here, and S to W has been given as 9 centimeters, so BN, of course, is also 9 centimeters because they're congruent. All right. Now what about side TW? TW is right here. Last two letters in this statement match up with the last two letters in this statement. So FN and TW are the same. So I guess that's going to be 14 centimeters because they are congruent themselves. Again, congruent parts of congruent triangles are congruent themselves. And then for the last side, BF, I look to my congruency statement. BF is the first two letters, going to be the same as ST. ST has been given as 17 centimeters, so then this is also 17 centimeters right here. Corresponding parts of congruent triangles are themselves congruent. This one's going to be very similar. And again, I urge you to fill out the whole picture before you start answering questions. Fill out the picture using the congruency statement up here at the top left. Use the congruency statement at the top along with the concept of CP/CTC to assist you. So let's move along. Press pause and fill out as much as you can in these two triangles. Then unpause. Press pause now. Now before you get going too far, or if you're still waiting for me to fill this out for you, which I hope you're not, you have to take a look at what's going on. In this initial triangle, they told me that this was an isosceles triangle. So GH and HJ both have a single tick mark on them. So GH matches up with XY, so I come over here, XY gets another single tick mark. And then HJ are the last two, so the last two over here is ZY, that gets a single tick mark. Now what about the side marked 18 feet? That's ZX. The first and last letters here are the first and last letters here. This is going to get a double tick mark to match up with those. So that means that that's 18. So I can put 18 feet here. And if that's 27 feet, then that's 27, and that's 27, and that's 27. Okay, well we got a lot of side stuff going on, so we can answer A, B, and C. I got GJ is 18 feet. XY is 27 feet, and because that triangle is isosceles, ZY is also 27 feet. Now, it's isosceles. Let's use that and run with the angle measurements. What I've done is I've taken this isosceles triangle and I've flipped it right side up so I can see that my 38-degree angle given was up here. Now I know it's isosceles because these sides were congruent. That means these angles are also congruent. So very similar to the isosceles and equilateral handout, homework number 3, we had a problem just like this. So I take that 38-degree angle and I back that off of the 180-degree sum of all three angles. It's going to give me 142 degrees. Now what's 142 degrees? Both of these angles add up to 142. So if I divide that by 2, I get 71 degrees. So each of these angles is 71 degrees respectively. And 71 plus 71 plus 38 adds up to be 180. So that's 71 degrees, that's 71 degrees, that's 71 degrees, and that's 71 degrees. How do I know all four? Because the two triangles are congruent, so according to CP/CTC, all the corresponding parts are as well. So now I just kind of zip around. Well, H is the same as Y in my congruency statement up here. So H must be 38 degrees. I answered that with no math. And then Z and J are already filled out. Those are 71 and 71. Fill out the picture. It makes your life easier. Promise. So now we're ready to use our congruency statements to help us solve algebraic problems. In this problem, we're given that triangle UVW is congruent to triangle TSR. And they would like us to solve for the variables x, y, and z. So for x, I have this value, variable expression 12x minus 7. And that has to do with side UV. So I look at UV, that's the first two letters of the congruency statement. That's congruent to side TS, which is over here, which is worth 53. So if they're congruent, I set the terms equal. And then I use my algebra to solve for x. You finish that one, and we'll move on to the y setup. For y, I see 5y minus 33 is referring to a side length. Which side length? RS. RS is the last two letters in our statement up here. Who's the last two letters in the statement over here? VW. Come over to VW, and lo and behold, that's worth 57. So 5y minus 33 must be equal to 57. Right? If congruent, set the terms equal. So now we have that to solve, and you finish that one, and you'll get an answer for y. Lastly, we have our z. So in the picture here, I see that z is related to UW. UW is the first and last letters. TR is the first and last letters here. TR is worth 50. So 3z plus 14 should be equal to 50. And you should be able to solve for the value of z. And that's about as easy as it gets. Finish those and then move on. Now as we move on to this question, we see that we're still solving for x, y, and z, but this time these refer to angle measures. So keep in mind that we may need to use the triangle sum theorem or something to do with isosceles triangles, or we have to be aware of everything at this point. Okay, so now what do we see? We see 6x minus 29 refers to angle H. Angle H is the same as angle N because they're both in position 2. And what do I see over here? Angle N is 115. So 6x minus 29 equals 115. You solve for x and you're all set. Next, we move on to angle P over here is 36 degrees. That's the first angle. That's the first angle over here, angle C. Angle C is dealing with letter Z. So 4z minus 32 is equal to 36. Now what about this angle F? That's dealing with the y. So I have 3y minus 1 is equal to something. And angle F is the last letter here. The last letter here is S. When I come over here, I don't know what S is. But I know that the green angled angle, or the green colored angle rather, is 115 degrees. So if we come over to the side and we say, well, I know I had 36 plus 115, and I'm going to take that answer and subtract it from 180. And I should get the measure of the missing angle that I've colored in blue, or angle S rather. So what is the measure of angle S equal to? Press pause and go through the addition subtraction to figure that out. Then solve for Y. By the way, you should have gotten that it was 29. When I add those two given angles up, it was 151. When I subtract 151 from 180, I get 29. So 3y minus 1 is equal to 29. You finish up and solve for y. Of course, our last version is going to be two triangles that haven't been drawn for us. So it's really simple. Just draw two triangles and place the information in. Press pause now, draw a triangle DEF, draw a triangle JKL, and then place all of this information in the appropriate locations. Press pause now and draw those in. Okay, now that I have a picture, I'm going to start going through some of the information here. So if we were to solve for the variable x, let's take a look here. I have the 9x minus 23 here and the 7x minus 11 there. And when I look at my congruency statement, df is going to be the same as JL, right? They're congruent. So this side and this side are congruent. So that means I could set these terms equal. So 9x minus 23 equals 7x minus 11. Once you get through the algebra acrobatics there, you should be able to get the answer for the value of x. And that's all they want is the value of x. Okay. What about my 3y minus 21? Well, that has to do with this length j to k. So again, if I'm looking at my congruency statement, JK, the first two letters here, should be congruent to DE. And DE is right here. So this side is congruent to that side. Again, notice I use one tick mark here to one tick mark here, and then 2 on DE and 2 on JK, because they're different lengths. But DE is congruent to JK, so 18 is equal to 3y minus 21. Solve for y, and we're all set. So that gets you through 8, and then you are to complete number 9 on your own. Good luck. Just a reminder, complete number 9 on your own, and then check in your notes, everything when it's all done for classwork credit. Thanks, and hopefully this was all helpful. As you work your way through 9 drawing the picture, here's a little help in the right direction. Okay, take care.